Here's our video to review factoring, and let's begin. So factoring is basically when you find which expressions you're going to multiply together to get another single expression. Multiply. So splitting the expression into a product is basically what we're doing. Product, of course, is when you multiply. And so if you have 6, then the factors are 2 and 3. But if you have something more complicated, algebraic, like x squared plus 4x plus 3, splitting those into two binomial factors, x plus 3 and x plus 1, that's the name of the game. That's what we're doing. So if we went from left to right, that would be multiplying, but we're going right to left, that's called factoring. So sometimes things have common factors. GCF, we call it, greatest common factor. And so the typical way to find greatest common factors is to list out all the different ways there are to multiply and get a number. And that's what you're seeing here. 56, here's all the different ways to multiply and get 56. 104, here's all the different ways to do that. And so 8 is the number that is in both lists, and it's the biggest number that's in both lists. So for example, if we wanted to find the GCF of 30 and 45, we might think of 30 as 1 times 30, 2 times 15, 3 times 10, and that's about it. 45 would be 45 times 1, or 1 times 45, 9 times 5, and I did miss one here, didn't I, for 30? How about 5 times 6? Okay, so the number that's the biggest, that's in both of the lists, is, oh, I missed one more, didn't I? There's one more on 45. That would be 15 times 3. I really wasn't too careful here. Anyway, 15 is the biggest number that goes into both of them evenly. That's the GCF. All right, let's see if I can do a little better job here on the next one. 12 and 54. So 1 times 12, 2 times 6, 3 times 4, and that's about it. 54, 1 times 54. 2 will go into 54 evenly, won't it? 54 divided by 2 is 27. 3 goes into 54, I'm sure. 54 divided by 3 is 18. 4? No. 5? No. 6 times 9, 54. Okay, biggest number that was in both lists. Well, looks like 6. So there you go. That's how you find a GCF. Now, sometimes we factor by a GCF. Also remember, GCFs can include variables. So we're going to find the greatest common factor of all the terms, especially the numbers. The GCF goes on the outside, and then everything else that's left goes on the inside. And so let's just do one. X squared plus 5, the GCF is just x. So you would have x on the outside, and then to get the inside stuff, you basically just divide, or you think to yourself, what do I multiply x by to get x squared? And that could be x, and x plus, or x times 5 would be 5x. So if I multiplied this back together, I'm going to get the original question. Let's do one that's a little more challenging here. How about number 4? So 18 and 6x, 6 is the biggest number, x is the biggest x they have in common. So basically I'm taking 18x squared and dividing it by 6x and getting 3x and minus, and 6x divided by 6x is 1. So nothing inside the parentheses should have a common factor. If it still does, it means you didn't take out the biggest or the greatest common factor. Let's do one more. Number 7, 6, 9, and 12. Biggest number that goes in there is 3, and x is the most common x. Then we'd have 2x squared, because we have to get x to the third. Then we'd have minus 9x. Sorry, not minus 9x, minus 3x. And finally, plus 4. Okay, so that's the idea of greatest common factor factoring. So let's move on to talk about these quadratic trinomials. Quadratic because they have the second power. Trinomial because there's 3 terms. So factoring a trinomial means finding the two binomials that when multiplied together produce the given trinomial. Inside of this, many of you have seen the x. And the x is just a graphic organizer that we're trying to multiply to get the top number, and we're trying to add to get the bottom number. And that's a very essential skill for factoring. So sometimes it's easy, sometimes it's hard. Two numbers that multiply to negative 108 and add to negative 3. Well, you might want to just break down 108. We know 108 can be divided by 3, and that gives you 36. And then 36 can be broken down 6 times 3. So basically, we're gonna talk about how to do this in detail, but you can take all the ways to, again, multiply and get 108, or actually it's negative 108, but just bear with me on that. 108. 2 will go in there evenly. 108 divided by 2 is 54. 3 we said goes in there 36. 4 should go in there. 108 divided by 4 is 27. And so let's keep going. 5 doesn't go in there evenly. 6. I don't think 6. 6 will. 6 divided by 3 is, no, I was doing, 108 divided by 6. And that's 18. Let's see, let's keep going. 7, 8, 108 divided by 8. No, that doesn't go evenly. 9, that'll go 108 divided by 9. 9 and 12, 9 times 12. Okay, now I know that this is going to be the pair because the separation between the two is 3. So one's 9 and one's 12, but then I got to figure out which one's negative. And since it adds to be a negative 3, that means that the 12 has to be the negative. Anyway, this is a skill that we're going to need to have for factoring in just a minute. So let's move on to, what do you do when the a value is 1? When the a value is 1, just make sure you've taken out the GCF. Then we draw some parentheses, we make a big X, and we make a T-chart. Well, you don't have to make the T-chart if you can do this in your head, but as you can see, for big numbers like 108, you need the T-chart. Determine what two numbers can be multiplied to get your AC term. What is the AC term? Well, the AC term, remember, all the positions in a quadratic trinomial are labeled either A, B, or C. So in this case, A is the 1 you don't see out in front, B is the 6, and C is the 8. So AC means you take the first number times the last number, you put that on the top. So 8 times 1 will go right here. The middle number is B, that's 6, that goes here. Now you think of all the factors of 8. You think of 1 times 8, 2 times 4, and that's about it. Then one of those pairs, hopefully, will add to 6. And this is the pair that does. So 2 and 4. That means the factored form is x plus 2, x plus 4. Those are the magic numbers that you can put in that will make this work if you multiply it. So it's pretty easy when the a is 1. Alright, so like for example, this first one here multiplies to negative 32 and adds to 4. That would be 8 and 4. And the negative, it has to have a negative because you're multiplying to negative 32. That would be right here on the 4. So this would be factors x plus 8 and x minus 4. And so on. So we're going to keep moving on. Now these are called area models. These boxes, they're multiplication boxes, but really they represent area because the area of a rectangle is the length times the width. One factor will be the length, one factor will be the width. You multiply everything together, add the stuff inside the box, it should all add up to what the multiplication is. So basically what we're doing is we're just either trying to fill in the box or we're trying to figure out what's on the outside of the box. So here's a complete problem we're going to go all the way through. So is there a GCF? No, not in this problem. So the big X is take the first number times the last number, put that on top. Put the middle number on the bottom. Take factors of the first, or the top, 6. So 1 times 6, 2 times 3, and that's about it. Now, is there a way that you can multiply and get a positive 6, but add and get a negative 6? And the answer is yes, you can, if you use negative 2 and negative 3. So now we take those two numbers, and we know it has to start with 2x squared. So we put 2x squared in one of these boxes. And we know it has to end in 3 because it's ending in 3. We put that in the other corner over here. The two numbers we just found are going to go in the other two boxes. So negative 2 and negative 3, but with x's. So really what that big X does is it tells us how we're supposed to split negative 5 to make this all work. Because remember, negative 2 minus 3 is negative 5, so that's negative 5x. Now, we got to figure out the outside of the box. You can figure it out by looking at the GCF, the greatest common factor of the rows or the columns. So let's take the first row right along here. The greatest common factor of 2 and 3 is 1. The greatest common factor of x squared and x is just x. So far, so good. Now look at the first column. What is in common there? What is the GCF? 2 and 2, so we have a 2, and x squared and x, so we have an x. Now, once you get those two, the rest of the box is going to fall just like dominoes. Right up here, this has to be x times what goes there to give you negative 3x. So that must be negative 3. And 2x times something is going to give you negative 2x. That something must be negative 1. There's the factors on the outside. X minus 1 in one direction, and 2x minus 3 in the other direction. And of course, the order doesn't matter. Let's keep going on here. These are special products. If we factor these, we're going to get x plus 7, x minus 7, x plus 5, x minus 5. How do I do this so quickly? Well, there's a pattern. X plus 9, x minus 9. And the pattern is that the a term is a perfect square. It is x squared. The C term, that's the term at the last, is also a perfect square. The B term is missing. The B term is 0. And of course there's a minus sign between them, so it's a negative perfect square for the C term. What do I notice about the factored form? Oh, it's very predictable. It's a plus and a minus, and it's filled in with the square roots. So the difference of squares pattern has that square minus square, ends up with a minus and a plus, and is filled in with square roots. And it's always two terms. Now here's some other kinds of special products. This one is x plus 4 squared. This is x minus 1 squared. And this is x minus 5 squared. Again, I know because there's a pattern. The A term, perfect square. Perfect square. It's x squared. The C term is also a perfect square. The B term is the square root of the perfect square at the end. It's going to have the square root of that C term. And the factored form, again, it has x plus the square root of that C term squared. So this pattern is called the perfect square pattern, perfect square trinomials. You see the description listed here. Okay, new topic. How do we get an equation from a graph? Well, we look for things called roots, also known as zeros. Roots are essentially just x-intercepts, places the graph crosses the x-axis. They are also called zeros because every point on the x-axis is something comma 0. So the zeros in the first graph here are -1 and +3, and the equation becomes x plus 1, x minus 3. That's right, it's the opposite. And over here on the right, the zeros are 2 and 4, and the factors are the opposites. This leads us to the zero product property, ZPP, zero product property. And it basically says when you have two things multiplied together so that you get 0, then one or the other is equal to 0. It's used to solve an equation. So just look at the first couple examples. X minus 2 equals 0, or x plus 4 equals 0. This is going to give you 2. This is going to give you -4. There's your two solutions. Now if it's just x, well then you just get x is 0. And then x plus 4 is 0, and x is -4. C is just a repeated root, a repeated 0. It's -3 twice, but we just write -3. If there's a number out in front, it has no effect on the 0. So, factoring and solving together. First, you need to make everything equal to 0. So, that means perhaps taking away 18x from both sides. So you get 3x squared minus 18x equals 0. Take out the GCF. So 3x and then x minus 6 equals 0. And finally, use the zero product property to find the zeros. So there's a 0, x is 0. 3 has no effect on the zeros, and x minus 6 will become the opposite, positive 6. There are the zeros. Oops, let's not put them in parentheses. Let's put them in curly braces. That makes them a set. Okay, so factoring solving when a equals 1, you just got to remember, you got to set the equation equal to 0. So in this case, the y should become a 0. And over here on number 4, you're going to move the 32 over, set it equal to 0. Now, what do you do when the a is not equal to 1? Well, then that's where you use that x and that box and everything. So if this is 0, we take our first number times our last. 5 times negative 3 is negative 15. 14 is the sum. Two numbers that multiply to negative 15 that add to 14 could be 15 and negative 1. That means that in our box we have, starts with 5x squared, ends with negative 3. 15x goes here, negative 1x goes here. Look at the first row, greatest common factor, 5x. Look at the first column, greatest common factor is x. 5x times 3 is 15x. X times negative 1 is negative x. There's our factored form. 5x minus 1 and x plus 3. And if it's equal to 0, we set 5x minus 1 equals 0 and x plus 3 equal to 0. Add 1 to both sides and divide by 5. So there's one answer. X is 1/5. And here's our other answer. X is negative 3. So this one and this one. Here's a summary of all the different things we've talked about. You might want to pause the screen right now and take a look at that, or zoom in on some of this. Okay, almost done. Radicals. Review of radicals. If you have a perfect square, then go ahead and take the square root. If you are trying to simplify a radical and it's not a perfect square, you want to find what makes up that number. And once you do, if you find a perfect square, take the square root of that and leave the rest inside. So 1/5 comes out, and then this little 5 right here, he stays inside. Okay, we can use that to help us solve equations that have perfect squares. For these, we take the square root of both sides. Don't forget plus or minus. Both of them will solve the equation. Here are some steps on finding square roots. Pause it if you need to. We'll stop at this one right here. This one usually busts people's brains. This is just 0. The square root of 0 is 0. Okay, now we're getting close to the end here. Determine the number of real solutions from the following graphs. This first one has 2 solutions. This second one has 1 solution. And this last one doesn't have any solutions. Real solutions. It does have imaginary solutions. This formula, b squared minus 4ac, is called the discriminant. It helps you to find out how many zeros an equation has. Again, a, b, c come from the equation. And here's the interpretation. If you have positive, coming out of that, then you have two solutions. If it comes out 0, you only have one solution. And if it's negative, you have two imaginary solutions. So we're going to skip over finding the discriminant because this all leads to the quadratic formula. The quadratic formula is used when factoring really doesn't work. Taking square roots is not going to do it because there's an x term. And for right now, we're ignoring completing the square. So here it is, the quadratic formula. That is worthy to be memorized. You notice inside of it is the discriminant. So I like to start out by finding the discriminant and then plugging into this equation. So let's see if we can do one of these here. The first thing you want to do is you want to identify your A, your B, and your C. Then calculate the discriminant, b squared minus 4ac. That's negative 13 squared minus 4 times 4 times 3. That's 169 minus 16 times 3, 48. And that would be, let's see, it ends with a 1. 6 minus 4 is 2. It's 121. It's positive, and positive means two solutions. Two real solutions, I should say. So let's do the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac, which we already found, all over 2a. So we got 13 plus or minus 11 over 8. Now we split the plus or minus. 13 plus 11 over 8, get an answer, and 13, excuse me, 13 minus 11 over 8. 13 plus 11 is 24, divided by 8 is 3. 13 minus 11 is 2, divided by 8, and that's 1/4. So our two solutions are 3 and also 1/4. Two real solutions, just as we predicted. Well, which is the best method to use? It all sort of depends. It depends on if something is factorable or not. If it's not factorable and we're ignoring completing the square for now, you might want to take a square root. You might want to use the quadratic formula. But if it is factorable, there's two different ones you want to think about. You want to think about if a is 1. Okay, those are usually fairly simple. Also, you might have a pattern, a special pattern. Or if a is not equal to 1, you use what we call the X box method. And of course, if there's a GCF, you always want to take the GCF out. Okay, that was about the quickest review of quadratics that I can do from Integrated 2. See you next time.